Hello guys, today we'll be talking about kinematics part 2. So let's get straight into it. So the first question we have a couple of values. So we have an airplane accelerates down a runway at 3.2 meters per second squared for 32.8 seconds until it finally lifts off the ground. Determine the distance traveled before takeoff. So first we have first we have this value, and second we have the acceleration. But we also have one more value. So when airplanes are going, it's this airplane, when they're traveling to take off, they're not moving at first, which tells us that the initial velocity is equal to 0 meters per second. So we also have that too. So what that means in this question is that, sorry, I'm just using a new application. It just means that we have acceleration, which is equal to 3.2 time, which is equal to 32.8, and VI, which is equal to 0. So we're calculating for distance. So the equation that we can use is distance is equal to, let me redo that. Distance, I don't know what's doing that. Distance is equal to VIT plus, sorry, that's a little bit hard to see. VIT plus 1/2 AT squared. So we have VI is equal to 0, which means that this entire portion is going to be cancelled. So we just have D is equal to 1/2 AT squared. D is equal to 1/2. A is equal to what? 3.20. T is equal to what? 32.8 squared. D at the end is equal to, let's use our calculator, 3.20 times 32.8 squared, 1721.3 meters. Okay, that's the first question. Second question. A race car accelerates uniformly from, why does it keep doing that, 18.5 meters per second to 46.1 meters per second in 2.47 seconds. Determine the acceleration of the car and the distance it traveled. So looks like there's no hidden values in this equation. We have VI, because it starts from 18.5, and we have VF, because it reaches up to 46.1 meters per second, and we have T, which is equal to 2.47. So we can use the equation that is VF is equal to VI plus AT, because we're calculating, we're calculating for distance. Oh, okay, sorry. So we're calculating for acceleration first. So we're going to have to use a different equation for distance. So VF is equal to 46.1, VI is equal to 18.5, and A we don't know. We're calculating T is equal to 2.47. And finally, if we solve all this, we will get 5 minus 46.1 minus 18.5 equal to 27.6 is equal to A 2.47. A is equal to 11.2 meters per second squared. So we have A now. Let's add it to our list of knowns. And let's get rid of this work right here, because there's a second step to this problem. It's asking for acceleration. So we can actually use any of the equations we want. So we could use VF squared is equal to, I don't know why it's doing that, vi squared plus 2as, or d, remember, in the last video, I stated that it could be d or s. D is equal to vit plus 1 half at squared. So just for the sake that vi doesn't cancel in this question, so it'll take a little bit longer, let's use the equation above. Vf is equal to 46.1. That squared is equal to 18.5 squared plus 2 times 11.2 times d. Putting that into calculator, we will get that, 1 second, 18.5 squared. If we simplify, we'll get 1782.96 is equal to 2 times 11.2 times d, which is equal to, d is equal to 79, oh no, 79.6 meters. Okay, that's it for this question. Next question. A feather is dropped on the moon from a height of 1.40 meters. The acceleration of gravity on the moon is 1.67 meters squared. Determine the time for the feather to fall to the surface of the moon. So, we have distance, acceleration, and that seems to be it. But we have one hidden value. So it says a feather is dropped, which means that the feather is not thrown down, right? No, he doesn't chuck the feather down. He doesn't do any extra. He doesn't add any extra force to the feather. The only force that is acting on the feather is the force due to gravity, which means that vi is actually equal to 0 meters per second. And d, we have 1.40 meters, and a, we have 1.67 meters per second square. So using these values, we realize that we can use the equation. We have vi, we have d, and we're looking for t, right? So we can use this equation. We can use the d is equal to vf, or vi, sorry guys, vi I squared. What am I doing? Nope, not squared. VIT plus, or let's make the t a little bit better, t plus 1 half at squared. Cancel out the VIT because vi is equal to 0. D is equal to 1 half at squared. D is equal to 1.40, equal to 1 half 1.67 t squared. 2.8 is equal to 1.67 t squared. So t is equal to, at the very end, 1.229 seconds. Okay, that'll be it for this video, guys. Thank you for listening. Next video we'll be discussing possibly more kinematics, but it depends on what we feel should be taught next. Thank you for listening, and we'll see you in the next video.